Hello everyone, myself Divya Kenchalgod. I am studying in BSc 3rd semester SSGFGC Nargund. My assignment topic is General Characters of F block elements with reference to the electronic configuration, magnetic property, color and oxidation state.
First, we have to study about F block elements. F block elements are commonly known as inner transition metals. They consist two series. First one is lanthanides and second one is actinides. These elements exhibits similarities in their electronic configuration and chemical properties due to the filling in f block element or f block orbital. If we talk about the position of f block elements in the periodic table, f block elements are placed separately at the bottom. The lanthanide series comprises the 14 elements. Following the lanthanum to cerium to lutetium actinides are 14 elements, succeeding actinum starting with thorium and exceeding lawrencium. Next, we have to know about the classification of F block elements. As we discussed, the F block elements are classified into two series. The lanthanides and actinides. The lanthanides belong to the 6th period and are located between group 3 and 4, while the actinides belong to the 7th period and follow the lanthanides. These series consist of elements with partially filled f orbitals. F block elements have general outer electronic configuration of n-2 F1 to 14 n-1 D0 to 1 ns2, where electrons fill with the n-2 f orbitals, making them inner transition elements. This unique configuration leads to several general characteristics. They are silvery white metals with high melting and boiling points, exhibit variable oxidation state, primarily +3. From colored ions due to unpaired F electrons tend to form complex compounds and the actinides are radioactive. F block elements means lanthanides and actinides generally exhibit a primary +3 oxidation state, but many also show variable oxidation state like +2 and +4. This variability arises from the low energy difference and poor shielding of their inner n-2f and n-1d electrons, allowing them to participate in bonding. Here, lanthanides and actinides. Lanthanides are 14 from cerium to lutetium, actinides from thorium to lawrencium. Next, we have to study about general characters of F block elements with reference to the electronic configuration and its impact. Filling of F block orbital, the most defining characteristic is the filling of the anti-penultimate n-2 f orbitals with 1 to 14 electrons. In lanthanides, these are the 4f series where electrons fill the 4f orbitals. In actinides, these are the 5f series where electrons fill the 5f orbitals. General configuration. The valence shell electronic configuration is n-2 f1 to 14 n-1 d0 to 1 ns2. The general configuration of the lanthanides is xenon f 4f 1 to 14 5d 0 to 1 6s 2. The general configuration of actinides is radon 5f 1 to 14 6d 0 to 1 7s 2. Next character is with reference to oxidation state. The common oxidation state is +3. All F block elements are readily form stable +3 ions. Variable oxidation states. Many elements, especially in the actinide series, show a range of oxidation state beyond +3. Lanthanides. Some lanthanides like samarium, europium and ytterbium can exhibit a +2 oxidation state. Actinides. These actinide shows even greater variability. The first few elements like thorium, protactinium, and uranium frequently display higher oxidation state such as +4, +5, and +6 respectively. Reason for variability. Similar energy levels. The energy difference between the n-1d and ns subshell is small, and for the f-lock elements, the n-2f, n-1d and ns orbitals have comparable energies. Electron participations. This small energy difference allows the electron from all these orbitals to participate in bonding, leading to multiple stable oxidation state. Shielding effect. The poor shielding by the diffuse f orbitals result in a greater effective nuclear charge for the outer electron, making them more available for oxidation. Relationship to reactivity. In relationship to reactivity, the ability of display a wide range of oxidation state contribute to the complex and highly reactive nature of F-block elements. Next property is color. Colored ions. F-block elements or their compounds are generally colored. Origin of color. The origin of color. This color arises from the electronic transitions of the electrons within the unfilled f orbitals, ff transition, into the visible light region, especially in complex ions. Next property is magnetic property. In this paramagnetism, due to the presence of unpaired electrons in the f orbitals, f block elements often show paramagnetic properties, meaning they are attracted to magnetic field. Varying magnetism. The strength of paramagnetism varies among the different f block elements depending on the number of unpaired electrons.